The cloud is one of the most misleading words in technology. It sounds weightless, infinite, almost invisible. But the cloud is not in the sky. The cloud is in buildings, massive buildings, filled with millions of machines, connected by fiber, powered by enormous amounts of electricity, cooled by industrial systems, and operated by some of the most strategically important companies on Earth. Every application you use, every website you visit, every digital service you depend on may be running somewhere inside this infrastructure. But most businesses do not own the machines. They rent them. They rent the storage, the compute, the databases, the networks, the security, the operating systems, the intelligence. And increasingly, they rent the infrastructure required to build the future. This changed the economics of technology because when a business stops buying the factory and starts renting the factory, the company that owns the factory gains enormous power. The internet did not disappear into the cloud. The internet moved into someone else's buildings, and the companies controlling those buildings became the landlords of the digital economy.
There was a time when building a digital business meant building the infrastructure yourself. You needed servers, you needed storage, you needed networking equipment, you needed security, you needed technical specialists, you needed physical space, and you needed to predict the future. How many customers would you have? How much traffic would arrive? How much storage would you need? How much compute would your business require? If you bought too much infrastructure, you wasted capital. If you bought too little, your system could collapse. This was the old internet. Every serious company built its own technological foundation. The infrastructure was expensive, slow, capital-intensive, and difficult to scale. The internet was growing, but the cost of participating in it remained high. Then a different model emerged. What if companies did not need to own the infrastructure? What if they could simply rent it? What if a startup could access the same category of computing power previously available only to the largest corporations? The answer changed the structure of the digital economy.
The basic idea was simple. Instead of buying the machine, rent access to the machine. Instead of building the data center, rent capacity inside someone else's data center. Instead of purchasing massive amounts of computing power, pay for what you use. This changed the relationship between capital and technology. A small company could launch with limited infrastructure. A growing company could scale without building everything from scratch. A global company could expand across regions faster. The infrastructure became flexible, but flexibility created a new dependency. The business no longer needed to own the machine. It needed access to the machine, and access was controlled by the infrastructure provider. This created a new business model. The infrastructure company built the physical foundation. Customers rented access to it. The provider earned recurring revenue. And as the customer grew, the customer's dependence on the infrastructure often grew with it. The startup was no longer buying a server. It was entering a relationship, and the relationship could last for years.
The economics began to resemble real estate. A landlord owns the building. Tenants occupy the space. The landlord provides the infrastructure. The tenants pay for access. In the digital economy, the building is a data center. The rooms are computing resources. The electricity is the energy required to run the system. The tenants are businesses, and the rent is generated every time they use the infrastructure. But digital landlords have one advantage traditional landlords never had. The building can scale. The tenant can use more space, more storage, more compute, more network capacity, and the bill can grow automatically with the business. The tenant does not need to negotiate for a new building. The infrastructure expands with demand. This is one of the most powerful economic models in technology. The customer grows, the infrastructure usage grows, the recurring revenue grows, and the provider becomes more deeply embedded. The landlord is not simply renting physical space. It is renting the operating foundation of the business.
Most users never see the infrastructure bill. They open an application. They click a button. They stream a video. They send a message. They make a payment. But beneath the interface, a complex economic chain is operating. Storage has a cost. Compute has a cost. Network traffic has a cost. Security has a cost. Data processing has a cost. Redundancy has a cost. Energy has a cost. And all of these costs exist before the customer sees the final product. The cloud does not remove the cost of infrastructure. It changes who pays for it. Instead of every company owning the entire stock, a smaller number of infrastructure providers operate the foundation. Thousands, perhaps millions, of companies rent access to that foundation. This creates enormous economies of scale. The infrastructure provider can build once, then serve many customers. The customer pays for usage. The provider continues to operate the system, and the economic relationship becomes recurring. The internet becomes a utility, and the utility becomes a business.
The greatest promise of the cloud was not simply cheaper servers. It was speed. A company could launch an idea, test a product, acquire customers, enter a new market, and scale infrastructure alongside demand. The company did not need to know exactly how large it would become. It could grow first, then pay for the resources it needed. This lowered the barrier to entry. A small team could build a global product. A new company could compete with established businesses. A developer could launch a service without owning a data center. The infrastructure became available on demand. This was a massive shift because capital no longer needed to be committed before demand was proven. The infrastructure became variable. The business could convert fixed costs into usage-based costs. But there was a trade-off. The company gained flexibility. The infrastructure provider gained a relationship. And over time, the relationship could become deeply embedded. The more the business grew, the more valuable the flexibility became, and the more difficult it could become to rebuild the entire system somewhere else. The cloud appears flexible, and it is. But flexibility does not mean independence. A company can technically move, but moving is not always easy. Applications are built around specific systems. Databases are configured for specific environments. Employees learn specific tools. Security systems are integrated. Data is distributed. Workflows are automated. The longer the relationship continues, the deeper the infrastructure becomes embedded. This creates a form of switching cost, not always a locked door, a complex door. The business can leave, but leaving requires time, money, engineering, risk, and uncertainty. The infrastructure provider becomes part of the company's architecture. And once a provider becomes part of the architecture, the relationship becomes more valuable. The customer is no longer simply renting storage. The customer is renting the foundation of its operations. This is the hidden strength of infrastructure businesses. They do not always need to lock customers in. They only need to become deeply integrated.
The economics of infrastructure are built on scale. A data center is expensive. A global network is expensive. Advanced security is expensive. Specialized hardware is expensive. But once the infrastructure exists,
It can serve many customers. The cost of building the foundation is enormous. The cost of serving the next customer can be much lower. This creates operating leverage. The infrastructure provider builds the system, then sells access to the system repeatedly. The same physical foundation, multiple revenue relationships, recurring usage, growing demand, and increasing utilization. This is why scale matters so much. A small infrastructure provider may struggle to justify the investment. A massive provider can spread the cost across millions of customers. The larger the system becomes, the more efficient it can become. The more efficient it becomes, the more competitive it can become, and the more customers it attracts. The economic engine begins to compound. The business is no longer simply selling technology, it is operating a global utility.
But the cloud has a physical limit: energy. Every server consumes power. Every processor generates heat. Every data center requires cooling. Every digital service ultimately depends on electricity. This creates a hidden connection between software and energy. The more the world moves online, the more physical infrastructure is required beneath it. And the faster artificial intelligence grows, the greater the demand for compute. The greater the demand for compute, the greater the demand for power. The cloud economy is therefore connected to the energy economy. A digital product may appear weightless, but somewhere, a machine is consuming electricity. A cooling system is removing heat. A facility is operating continuously. A network is transmitting data. The future of the internet will not be limited only by software. It may be limited by physical infrastructure, land, power, cooling, hardware, and the ability to build fast enough. The cloud is digital at the surface, but physical at its core. The cloud is not made of software alone. It depends on hardware, processors, memory, storage, networking equipment, specialized accelerators, and the factories that produce them. This creates another layer of dependency. The cloud provider may control the data center, but the data center depends on hardware. The hardware depends on semiconductor supply chains. The semiconductor supply chain depends on specialized equipment, and the entire system depends on energy. Every layer creates a potential bottleneck, and every bottleneck creates strategic value. This is why the future of cloud infrastructure is connected to the future of semiconductors, the future of energy, the future of industrial capacity, and the future of artificial intelligence. The digital economy is not floating above the physical world, it is built on top of it. And the companies controlling the deepest layers may become more important than the companies selling the most visible products.
Artificial intelligence is changing the economics of the cloud. Traditional software often needed storage, databases, networking, and general computing power. AI systems add another demand: massive amounts of specialized compute. Training models requires infrastructure. Running models requires infrastructure. Serving millions of users requires infrastructure. Autonomous agents require infrastructure. And as intelligence becomes embedded into more products, the demand for compute increases. This creates a new question. What happens when every company wants intelligence? The answer is not simply more software. It is more infrastructure, more processors, more data centers, more energy, more networking, more cooling, more capital. The AI economy may therefore strengthen the position of infrastructure providers, because the more intelligence the world wants, the more compute the world must rent. And the more compute the world must rent, the more valuable the infrastructure becomes. The next great technology competition may not happen only at the application layer. It may happen beneath it, inside the machines that make intelligence possible. The cloud changed more than technology. It changed the relationship between businesses and assets. A company no longer needed to own every machine it used. It could rent access. A startup could rent compute. A retailer could rent infrastructure. A bank could rent technology services. An AI company could rent processing power. A developer could rent databases. The entire economy could become more flexible. But flexibility created a new form of concentration. The more businesses rent infrastructure, the more important the infrastructure providers become. The more businesses build on the same foundations, the more powerful those foundations become. This is the paradox of the cloud. It democratized access to infrastructure, but it also concentrated control over infrastructure. Millions of companies can now access powerful systems, but a smaller number of companies may operate the systems they access. The technology became more available, the infrastructure became more concentrated, and the landlords of the digital economy became increasingly important.
The cloud is often described as a technology story, but it is also an industrial story, a capital story, an energy story, a geopolitical story, and a power story. Because whoever controls the infrastructure controls the capacity of the system. The businesses may compete above it, the applications may change, the products may disappear, but the infrastructure remains. And as more of the economy depends on digital systems, the infrastructure becomes more important. This is why the most valuable asset may not be the application. It may be the foundation beneath the application. Not the website, but the compute. Not the software, but the infrastructure running it. Not the AI product, but the machines making intelligence possible. The future will be built by millions of companies, but many of those companies will operate on a much smaller number of digital foundations. And when an entire economy rents the same foundations, the owners of those foundations gain extraordinary power.
The cloud was supposed to make infrastructure invisible. Instead, it made infrastructure more important than ever. The world moved online. Businesses stopped building every machine themselves. Applications became dependent on shared systems. AI created a new demand for compute. And beneath the entire digital economy, a physical architecture continued to expand. Servers, networks, energy, data centers, processors, cooling, capital. The cloud is not an escape from the physical world. It is the physical world, organized into a new economic model. A model where access replaces ownership, where infrastructure becomes a service, where businesses rent the machines beneath their own businesses, and where a small number of providers can become the landlords of the digital economy. The question is no longer, who owns the application? The deeper question is, who owns the infrastructure that allows the application to exist? Because the future will be built on systems, and every system needs a foundation. The companies that control the foundation may not always be visible, but they may be collecting value every time the digital economy moves. This is Nexera, decoding systems, architecting wealth.